This is page 76. So there were only two types of angles. There were central angles and inscribed angles. We already learned central angles equal their arcs. And now what we're going to learn is the relationship with inscribed angles. Couple of things to refresh you on. Then there's two special case scenario pictures to look at that can sometimes come up. And then we have practice problems. The practice problems start out with just numbers. Then it goes to solving for x. Then it goes to solving for x and plugging it back in. Okay, so there's 3 levels of difficulty in the practice problems. So first of all, an inscribed angle is an angle with its vertex on the circle, and the two sides are actually chords. If you were to emphasize the 3 endpoints of the angle, you would see that all 3 of them are on the edge of a circle. Okay? If you'll take your earbud out for me. Audrey, will you take yours out too? You don't mind. So the central angle, remember it came from the center. The inscribed angle, all of the points are on the circle itself. The intercepted arc, meaning if you think of a flashlight as the angle's opening up, the arc that's in between. So in this case, it would be this arc right here. It's the arc that lies between the, is this endpoints? Yeah, endpoints of the inscribed angle. So angle, watch how I trace it. Angle A, B, C. If it's an angle, you should be going inside the circle to trace it. Is opening up to form arc AC. Okay? Now, what's the math behind it? Well, if you go back to central angles, one of the tools in our toolbox was that an entire circle is 360. A diameter cuts the circle in half, which implies 180. If you have 2 diameters, then you have vertical angles, which means you have, we said, vertical arcs. I don't know why pi is written right there. I think someone did that to be funny. And then we learned that central angles equal their arcs, right? That was last week. Now what we're learning is inscribed angles. Do you think they're equal, or do you think it's a different relationship? It's a different relationship because the elbow, the vertex, has been pulled back. It's no longer at the center. It's been pulled back to the edge of the circle. The degree of the inscribed angle is equal to half the measure of its intercepted arc. The angle ABC equals half arc AC. So if you're going from the angle equals half the arc, we could reverse it and say, we're going to say, or, dot, 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 the arc equals, what's the reverse? If the angle equals half the arc would be, go in reverse. What's the opposite of half? If I cut something in half, what's the opposite of that? What's the opposite of divide by 2? Multiply by 2, thank you. So the arc would be double the angle. That's another relationship. Some people prefer it that way because there's no half. You know what I mean? Like, It just depends on which one you don't mind working with. Now, how are you going to remember that? Let me show you this. This is stupid, but it works. All right, we're going to have a central angle, and then I'm going to draw an inscribed angle. Central angle comes from the what? The center. This is the center right here, right? And the arc it opens up to, right there, we learned last week that it equals it, right? So this is x degrees, then this would be x degrees. Okay, inscribed angle is actually on the circle. So this is inscribed right here. The arc it opens up to is here. But we learned that they're not equal. One is double the other, or one's half the other. Depends on what direction you're looking at it. All right, so I'm going to show you something. We said that the angle was x, then the arc would be 2x. Okay, how are you going to remember, number one, which one is 2 and which one's half? How are you going to remember that central is equal and inscribed's not equal? So y'all know me, I always relate it to food. Piece of cake. Piece of cake implies easy, right? Look at this picture. You had a round cake in front of you. Is that how you typically see people slice a piece of cake? They just take the knife and go to the center and then create like a triangle, and then that's a piece of cake, right? So if it's how you would cut a piece of cake, double check, does the vertex of the angle meet at the center? Then it's a piece of cake, which means it's equal. A piece of cake means easy, simple, right? All right, now this one, no food here, but everybody's favorite. I want you to think snow day. You might be thinking I'm crazy. Hold on, stay with me. Michaela, stay with me. All right. Remember the phrase, go to what you know. Go to what you know. We've talked about that before. Whenever you're doing these problems, always go to what you absolutely know. And then ask yourself, what is it you need? So if I go to the inside, let's say this was 20. Go to what I know. And I'm coming outside. I want you to think snow day, because this is inscribed. When you go out to play in the snow, what do you do with your layers? You double your layers, right? So you'll last longer in the snow. You put on a jacket, gloves, hat, whatever. So coming outside to go play in the snow, I double the 20 and it would be 40. Okay? Now let's switch it. Let's say this was 60 degrees. And I was looking for the inside. I'm going to go to what I know. I know the 60. Now I'm going to look at what I need. I'm coming inside. When you're done playing in the snow and you come inside, you half your layers. You take your jacket, your boots, your hat, your gloves off, right? So you half your layers to come inside. So this would be 30. Another way to remember is the angle is the smaller one, the arc is the big one. So it's kind of backwards from the words themselves. Arc is the shorter word, but arc is the bigger measure. That's another way. But snow day has helped in years past when I've taught this. Snow day has helped tremendously for people to remember when to double, when to half it. That's the problem. When do I double? When do I half it? If you'll think of a snow day and go to what you know and then look at where you're trying to find, then you'll know when to double or half it. Okay? So let's come right here and let's just write snow day. Come right there and write snow day. let's call the angle x degrees, and then the arc on the outside 2x. All right? All right, two pictures of special circumstances that sometimes come up. Not always, but sometimes. You had it? Look at this one. Intercepting a diameter. Look at the picture. Name the diameter by 2 letters. What's the diameter? BC. Do you notice how angle, watch how I trace it, CAB is opening up to that diameter BC. Do you notice that? And do you notice what shape does it form? It's a triangle. Okay? Let's apply the snow day logic. Find the angle. Stay with me, Adriana. The angle is right here. This is the angle. I'm just going to put a dot right now. Follow the edges of the angle to see what it's opening up to. Angle CAB is opening up to this arc here. What's the vocab word to describe that arc? It starts with an S. And it's because of the diameter. Semicircle, yes. It's exactly half the circle, which means we actually have a measurement here. So how many degrees is in this semicircle? 180. If we go to what we know the semicircle is 180. Now we're coming inside from playing in the snow, so I do what with the 180? I'm coming inside. I have it. So what do I get? 90. So what type of triangle is that? A right triangle. If an inscribed angle intercepts the diameter, then it's actually a right angle, which means you actually have a right triangle. And that is every single time. Now, certain conditions have to be met. First of all, it has to be an inscribed angle, meaning all 3 letters of the angle are on the edge of the circle. Second of all, the hypotenuse of the triangle has to be the diameter of the circle. So maybe make that note. The hypotenuse of the triangle is, I'm abbreviating, the diameter of the circle. When the hypotenuse of the triangle is the diameter of the circle, it's a right triangle. Every time. Which means you actually know 2 measurements. You know the 180 arc and you know the 90-degree angle. So that will come up. Okay, one more. The picture looks crazy, but it's one of the easiest concepts. This picture has a bunch of chords in it and angles. Let's address this angle here. Do you see that angle? ABD, angle ABD. Can you trace with your eyes or on your paper with your fingers, trace angle ABD, and I want you to put your pencil on the arc it opens up to. So think of it as a flashlight. I want you to put your pencil on the arc that angle ABD is shining to. Now, can you name the arc with 2 letters? Did you say that? Arc AD. So notice angle ABD, think of a flashlight, is shining to this arc right here. Can you name another angle that's shining to that exact same arc? What? ACD. Do you notice that? Do I know any actual measurements in this picture? No. But I do know because angle ABD is shining to the same arc as ACD, then these 2 must be equal. So this is a congruent property, that if you have multiple arcs multiple angles shining to the same arc, the angles must be equal. All right, so let's fill in the blank. This would be congruent. And angle ABD would be equal to the measure of angle ACD. And that's because they share arc AD. Okay. Diving into the practice problems. We've got a lot of things that you should have in your mind. I've run out of room on my marker board over here. You need to keep in mind 360 is the total. Diameters cut the circle in half. 2 diameters make vertical angles. Central angles equal their arcs. Inscribed angles make snow day. I want you to go to the picture and put a question mark on what it asks you to find. It's going to help direct your thought process to get that question mark. So number 1, it says, what is the measure of angle WXY? Notice it says angle. So go in the picture. WXY is this angle right here. So that's my question mark. The first thing you need to do is look to see, do you know its arc? Do I know the arc that angle is opening up to?
Yes.
Yes, which means this is short and sweet. Now you ask yourself, what type of angle is it? Is it a piece of cake or is it a snow day?
Snow day.
It's a snow day. The whole sheet's a snow day, right? So please don't try a piece of cake in there. It's a snow day. It helps if you draw the squiggly on the arc so it kind of makes your eyes line up with it. You're going to go to what you know. I know the arc is 62. I'm coming inside from a snow day, which means I do what with 62? You half it. And you get 31. Number 2. It says, find the measure of DGF. And it's talking about an arc, which means we're tracing around the circle. All right, let's take our pencil and let's shade arc D to G to F. We're going to put a question mark there because that's going to help direct our attention to it. That's the arc. Go inside and see, do you know the angle that forms it? Do you know the angle that forms that arc? Yes, you do. Go to what you know. Remember this phrase. Go to what you know. Then go to what you need, and that's where snow day comes in. I'm coming outside to play in the snow, so what do? You're going to, what'd you say? If I'm going outside to play in the snow. Double it? Is that what you said? All right, well, I want to make sure you get it. So if I know this number, but I'm coming outside the circle, I would double it. Another way to, especially when it's a picture like this, another way to know, like if you start to think I'm going to half it, half of 113 is what? 56 and a half? 56.5. Okay, so if you look at this picture, is there any way that arc would be 50? No way. So that's another safety net, like if you think to yourself, does that make sense for the arc to be 56 degrees? And in that case, no. Number 3. You might think number 3 is challenging because they don't put a single number in there, but we just learned it. That is a triangle that is inscribed within the circle. Yes. PR is the diameter, which means that this over here is 180. And the goal is angle PQR, which means this is the goal. I'd be tracing inside to that angle, and it would measure what? 90. Okay, so now what we're doing is getting into the ones where the questions are not direct, meaning it's not a one-step problem. Now there are two-step problems, but you still start it the same way. You go to the picture and put a question mark on what they ask you to find. In this case, it says to find arc BC. It helps if you go to the arc and you draw the squiggly, because then in your mind it'll stick out. So I need arc BC right here. I don't know it. Then you're going to remember this rhyme. Go to what you know. What do I know? Because I know something in the picture. What do I know? First of all, there's a semicircle. Do you notice that you have a diameter in here? So like from here to here measures what? 180. What else do I know in the picture? There's a 47. I'm going to start with the 47. 47 is right here. Think of a flashlight opening up. What would the measure of the arc be that the 47 creates? What? Yeah, it's a snow day, so you're going outside, so you double it, and you get 94. And now you should be able to see that we have a total minus a part we don't need, and it's going to leave us with the part we do need. The total's 180. We don't need the 94. If we subtract 94 off of 180, it would leave me with the squiggly question mark. What do you get? 80? What? 86? All right, number 5. Put a question mark on what it asks us to find. It asks for you to find angle JKL. Angle JKL. So this angle is what they want. Always ask yourself, do I know the arc? That's the relationship. Always go from like, do I know the angle? Do I know the arc? Do I know the arc? Do I know the like? You check those first, then you work your way out. Do I know the arc that opens up to? Well, first of all, it opens up to what arc? Is it minor or major? It's a major arc. It's opening up to L. All the way to J. Do I have enough info to get the arc from L all the way to J? How do you know? Remember, one of the tools that you're supposed to keep in mind is that the whole circle measures what? 360. Stay with me, Landon. The whole circle measures 360. This arc that I just shaded is the only piece of the whole circle that I don't know. I know this piece and I know this piece. So I have enough info to find the measure of that arc. So 360 minus 53 minus 65 is what? What is it? 242? So if the arc is 242 and I'm coming inside from playing in the snow, what would the angle be? 121? Number 6, it asks for two angles, RST, RUT. our ST is here, and our UT is here. What do you notice about those angles? What arc do they open up to? RT. So if I find one, I've actually found the other one because they're congruent. Now, do I have enough info to find RT? Stay with me, Ardrina. Yes, I have the whole circle, but one piece, right? So 360 minus 64, 139, and 75. And what do you get? 82. So if the arc is 82, coming inside the angle would be a snow day. Coming in, it'd be 41. All right, now let's level it up. Instead of just numbers, now we have expressions of x. But you're going to do it, you start it the same way, okay? The goal is find the measure of the arc or angle where the expression of x is, and then that's your equation. So coming to this picture, it says 8x minus 9 is this angle right here. So I'm going to draw an arc to draw my attention to it, and I'm going to put a question mark there. Do I have enough info to get the measure of that angle? Yes, I do, because it actually tells me the arc it opens up to. Do you notice that? If you trace it, that angle is opening up to arc CE, and I know that that's 158. Okay, so go to what you know. I know 158 is on the outside. I'm coming in. So I do what with 158? What? Wait a minute. Coming in now. It's okay. We're going to get there. That's why we're doing it right now. If I'm coming in from playing in the snow, I'm going to take my half it. I'm going to take my layers off. So half 158, and what do you get? 74, 79. I don't have enough room. Oh, I'll just put, okay, so I'll just write it here. So that mess, 8x minus 9, has to equal 79 degrees, and that's your equation. That is your equation. Now, if you don't see it that way, you could go this way where the arc equals 2 times the angle. You could just copy that and go that way. Arc equals 2 times the angle. That's another technique. Just make sure the arc and the angle correspond, okay? Make sure it's not like a piece on the outside. I personally don't like that technique because it takes longer. It's an additional step and the numbers are bigger. If I have enough information in the picture to actually get the degrees in that arc, in this case, then I just get the degrees and then I set that equal. You know what I mean? What did you get for x and 7? Yeah. All right, 8. Go to what you know. I know the angle is 67. If I'm going outside to play in the snow, I better double my layers so I don't get cold. So what would the outside be? 134. And now what you've just done is found your equation. 4x plus 58 has to equal 134. You get 19? All right, you have 8 practice problems on the back. You should get nice, pretty numbers on every one of them, and they are the same stuff we've been doing. On 9 through 12, you're just solving for x. On 13 through 16, you're solving for x, and then they want you to plug it back in, okay? I'm going to write the answers on the board so you have a checkpoint. But you should be showing your work, okay? So on these, since it's solve for x and then plug it in, I'm not going to write what x is because then that would take away the plug it in part. I'm just going to write the final answer. So you have to get x equals, then you have to plug it in. Your final answer is over here.